6x to the 5th power. If we're taking the derivative of him.
What are we doing?
I'm in between example 4 and 5. But I'm reviewing. 6x to the 5th power. Let's talk about him.
30x to the 5th.
Okay. We take the 5. We move him down in front.
Yes.
But there's already a 6, so that makes it
What number are we?
30x to the, I'm making this up.
5x.
We're in between example 4 and 5. 30x to the 4th. Okay.
1 minus.
Yep, 1 minus. All right, let's do another one. Let's say I have negative 3x to the 5th power.
Negative 15 to the x to the 4th.
Negative 15x to the 4th. Okay. All right, now let's do a couple more that are really a little bit harder. Let's say I have 1 over x to the 4th power. How do you find the derivative of him?
1 over 3x, 2x to the
Hold on, I'm going to move the 4 to the top, x to the 4th to the top. If I put him to the top, he is now x to the negative 4th. True? Okay, now I find his derivative. So I move the 4 down in front, negative 4, and I subtract 1, so that makes him to the negative 5th power. Right? Negative 4 minus 1. Okay, now I move him back down. Negative 4 over x to the 5th. Yeah?
Do you have to do that?
Okay, yes.
Question. Why
That's how you
can't you
have
just
to
leave
do
it?
Could we, like,
What do you mean?
It
Oh,
has to go back to the
Just
top.
leave it.
if you're going to take a second derivative, just leave him. Don't move him back down because you'll have to do it. Move him back up again.
I
and
was
take a second derivative.
derivating yesterday.
Yeah,
And
you would.
Oh, I meant the second leave it there.
They will tell you. I want the second derivative.
So,
Otherwise,
like-
you're just taking the first derivative.
Can we not break the 30x to the 4th down more? Can you not take 4 times 30 and then have...
That would be the second derivative. But you're only doing the first derivative. We'll do a second derivative here later, okay? So, let's go to this guy, example 5. Okay? This is the notation, just so that we're familiar. D over dx means the derivative with respect to x. That means the variable that I'm looking at is x. Okay? So it's just saying take the derivative with respect to x. Find the derivative. Okay? 2x to the 6th power. Let's figure him out. What is that? 12x to the 5th. Got it? Okay, let's take the derivative of x to the negative 9th power.
Minus 9x
To the negative 10th, right? Negative 9 comes down in front. I subtract 1 from the exponent. Got it? Okay? All right, now let's fix the 10.
No.
Let's bump him down to the bottom. So he is 12x. Okay, hold on. 12x to the 5th minus 9 over x to the 10th power. Okay? Here is what you do not do. Ready? This is a separate term, right? This is not all one piece together. So I can see people taking that x to the 10th and putting the whole thing and x to the 10th on the bottom.
No.
This is separate. So he is the only thing that has x to the 10th on the bottom. Chase, very good away. Okay. X to the 10th goes on that guy. Got it?
Yeah.
Good? You too. I see you. Put it away. Last chance, or I'm going to make you put it up. Like it's supposed to be in the first place.
Eli.
Yeah. Well, they're not on them though. Okay.
Yeah.
All right, this one. You have to do some simplifying before we can.
We're not done?
No.
No, this is the next one. This is an altogether different problem. So we're taking the derivative. Okay. Let's do this.
By the square root of x.
The square root of x over the square root of x minus 2x over the square root of x.
Can it not just cancel? The square root of x.
You betcha. So if I take those and separate them apart, this, the square root of x and the square root of x cancels, and that makes 1.
Oh, I thought
Yeah?
you meant the bottoms.
Yeah?
Were you talking about the bottoms or were you talking about
No,
the first one?
like the first one.
Okay, now, this guy. Pay attention to this one.
Yeah, Jalen
This is x to the first power. This is x to the 1/2 power. If I move the 1/2 power up to the top,
No.
it's x to the negative 1/2 power, yeah? So, and now I'm going to combine those x's. So it's x to the first and x to the negative 1/2.
Okay, wait, I have a question.
Oh, wait, what are we
In the beginning,
Just x to
Just
the
x to the 1/2,
square root
right?
of x is trapped. Why can't you split it up?
Okay, go back. What?
It's trapped.
What do you mean?
The square root of x is trapped. Why can't you just split that like that?
You can if he's on the bottom. You can't if he's on the top. Like in the quadratic formula or whatever, we have negative b plus minus the square root of, I'm just making these numbers up, all over 2, right? This is like negative 3 over 2 plus minus 6 square roots of 2 over 2. Like I can do that. I can separate them into 2 pieces. What I cannot do is if I have like 4 plus x and then 2. Here's what I can't do, Reese. I can't do this. I can't make this 1/2 plus 2 over x. Like that doesn't work. You can separate them if they're on the top, but not on the bottom.
One time Luke's not in here, and I actually have a question.
Does that make sense? No?
Yeah.
Okay, because think about it this way. Let's say that this is 3/4 and let's say that this is 1/4, right? I can put those together and make it 3 plus 1 over 4, which is 4 over 4, right?
Yeah.
If they have the same bottom, you can put them together or you can break them apart. Like this right here is that.
Really? It wouldn't. Oh yeah, because when you add
Right?
them,
With 3/4 plus 1/4.
when you're adding, you have to find a
4/4.
common denominator. So
Yeah.
it's just like
Yeah.
okay, yeah. That makes
So if they have this, like the bottom, you can separate them into 2 pieces. But you can't do it reversed if you have, like this guy.
It exploded.
If you have 2 numbers on the bottom, this doesn't split up into 2 like that.
on me?
That's just the way that works.
Why am I so nice?
Okay. So let's go to this guy. So now we have it to this point. And now we have to find the derivative.
Like when we factor stuff out, it's like no, you can't do anything with it.
What do you mean?
No, I
It's
can't.
all start crying.
You could literally
What?
bully
I don't know.
me.
I
And
don't
I'd be like,
I don't know. Okay, finding the derivative.
I'm just gonna leave it.
All right, are you guys all to this point? This guy right here? We have to find the derivative of him. What's the derivative of 1?
0.
0. Any constant just poops out and goes away. Now I'm taking the derivative of this guy. I moved the exponent down in front.
1.
Okay, negative 2 times 1/2 is negative 1. X to the, if I subtract 1 from 1/2, negative half. Okay, and now we put him back down to the bottom.
Wait a second.
So
So negative 1 over square root of x.
So 1/2
Yeah.
times negative 2.
We literally didn't do anything there.
But 1/2 minus
what?
1.
Because now we can't have the thing on the
One
bottom.
of these guys.
What?
You can't have that guy on the bottom.
Well, we're gonna leave him.
Looks like you.
I'm not gonna make you guys rationalize derivatives. Yeah.
wait, okay, so
We're not gonna do
when
that.
that becomes
So like if it is to the half power, like to completely simplify it, you need the square root.
Yes. Yes. Yes.
hang on.
Okay.
Then becomes negative 1 over x to the
What did
half.
you just say? Say that again.
If he's to the 1/2 power, to simplify him, we make him a square root. She says like, can we just leave our answer like this? Technically that's right, but
So
if
we
you want to
have
write
to
him pretty, you would put him as a square root.
and then we find
In the simplest form.
Yeah, we did not start on a good example today. Let's go to something easy. Let's do this one. Here we go. Easy. Much easier. Much easier. Here we go. Let's do
Okay,
this.
explain it.
We have 4 pieces. Find the derivative.
There's no half powers, there's no negative powers.
3x to the 8th power. Here we go. 3x to the 8th power. 3 times 8 is 24x to the 7th. Perfect.
Minus
5 comes down in front. That is
10x to the 4th.
10x to the 4th. Plus
6. No, nothing. Wait, no, that's just 6.
6 because there's a 1 there, right? So the 1 comes down in front
And
times
then
6.
x
This is
goes
x to the
away.
0. And then what happens to the derivative of 1?
0.
Boop.
Gone.
Right?
Wait.
Everything is
Oh.
1x less than what it was before, right? So this guy doesn't have anything because we didn't have x. This guy is less than x. This one goes to the 4th power.
Wait,
This goes
so
to the 7th
do we
power.
bring down x to the 0 power?
No,
or do we just
I don't
go to
write x to the
6?
0 power. I just leave it as 6. Technically he's 6x to the 0 power, but I just leave him as 6.
Wait, but
Got
isn't x to the 0 power?
1. Anything to 0 power is 1. So it's like 6 times 1.
But that one.
But it doesn't
The next
have
one.
Now, Reese. This is x to the 0 power to begin with. So technically the 0 comes down in front, multiplies by the 1. This is 0x to the negative 1 power, right? This guy, when he's done, he is x to the 1st power. But when you subtract 1 from the exponent, then he's x to the 0 power. Does that make sense?
It starts out as 1.
He starts out as 1. He doesn't end as 1. Okay, confusion? Should we do another of those?
No, that
Let me
makes
give you a big one.
No.
Negative 5x to the 5th minus 3x to the 4th plus 7x squared minus 2x plus 14.
Angel, we're gonna
Find
go
his
over.
derivative. Go. I made that up. Write that down. Write that down right
What was
below
the
and find
answer?
his derivative. Go.
What was was the answer? Was that just the answer? We just simplify it?
Right there. That's,
Minus
this is his answer, that's all.
So,
And find his derivative right here. Do that one.
This?
Negative 25x4. 12x3.
Can I ask a question on number 2 for stats?
Okay, find his derivative. Did you find his derivative? Chase, did you find his derivative?
Yep.
You did for sure?
Yep, I think so. I hope so.
2.
Is the value 23, 27, 50 cents?
Oh my gosh,
No,
I'm so stupid.
6. Okay. If we add all
Eli,
of it
find
to
the
zero,
derivative of it.
That one is.
Is that how you
Are you kidding me?
add
Plug
all
in
the
zero.
Right, is this
No.
value of 27 the mean?
You get to do
No.
each one.
Paid by
Okay, each one.
What have we been
There are
doing?
more people in California.
Okay, so negative
Read this.
25
So that is
Starting
way
at
better.
work
That's
number.
not- Anytime they have anything to do with states, you don't want to count the states equally because they're not
Because they're
proportional.
not proportional.
Right. Okay, so did you get this answer? The 5 comes down in front. Negative 25, x to the 4th minus 12, x to the 3rd plus 14x minus 2, and then what happens to 14? He's 0. So this is like plus 0 on the end, but you don't have to have the 0, right? That's his derivative. Got it? Okay, here we
So
go.
wait, was it negative 25x to the 4th minus
there.
12x to the 3rd?
Plug in 0.
Plus 14x minus 2. Okay, all right, here you go. All right, it's getting harder. We have a problem that's going to take a little bit of time. So full attention here. It's not that hard, okay? Full attention here. Are you ready? Here you go. Ready,
Everything is like
set, go. We're just all squirrely today. I don't know what the deal is. Okay, ready? Okay, here we go. Let's talk about what this is meaning. We're going to do this a lot, so you boys are listening.
Yep.
You boys are listening.
Yep.
Please look at the screen so I can have your full attention just for this 2 seconds. Okay? All right, this says at what point? Here we go. At what point or points, if any, does this graph have a, circle the word horizontal tangent line? Horizontal tangent line. Okay? Horizontal tangent line. I'm going to cheat and look at the graph. Ready?
Then what do
Yes.
you do?
Horizontal tangent line. Okay, here is my tangent line, here is my tangent line. At those tangent lines, the slope is going to be 0. The slope of the tangent line equals 0. What's another name for slope of tangent line?
Derivative.
So the derivative is equal to 0. So if I want to find the location of those points, I find the derivative and set him equal to 0, because that's where the slope is 0. Make sense?
Sure.
Do I need to say that again?
Oh, so you just plug
The derivative. So let's find the derivative of that. What's the derivative of that?
Is it like
negative
negative 2.25?
Minus 3.
X squared.
And that's it. I want to set him equal to
0.
0. My slope, that derivative is slope. Slope of tangent line. I want to set my derivative equal to 0. So let's solve.
3x squared.
Add the 3.
3
3x squared equals 3. Divide by 3.
squared
Oh, just
equals
kidding.
1. Square root of 1 equals 1.
Close. What's the
Plus
square root of 1?
minus
Plus minus 1. Okay, so where is he going to have a horizontal tangent line? At positive 1. Oh, looky there. And at negative 1. Oh, looky there. Do you see those?
That was not that hard.
Hey, that was not that bad.
Wait.
So, horizontal tangent
I like
line.
those ones.
Horizontal tangent lines are going to have a slope of 0. Slope of 0 means derivative is 0. So you set the derivative equal to 0. Okay?
9 minutes.
All right. Next.
9 minutes already.
Yeah.
I don't want to do example 8. Let's go to higher order derivatives, example 9. Okay? All right, let's look at the notation. They say higher order derivatives. This is Jalen's problem.
What the fuck?
This guy is saying the first derivative.
Third derivative.
This guy is saying the
fourth
second
and fifth.
derivative. This guy is saying the third derivative. Then we have the fourth derivative and fifth derivative and all the way down and all of this stuff, right? Okay? So we're going to take the derivative once. What's the first derivative look like?
12x to the third.
Okay.
Minus 6x to the second plus 1x.
2x.
Minus 4.
2x.
Oh shoot, yeah. 2x.
2x.
Minus 4.
Minus 4 and the 2 goes away, right? Okay? Now let's do the second derivative. So we're doing the derivative of that one.
36x squared.
36x squared minus
12x
12x
plus
plus
2.
2. The 4 goes away. Okay, the third derivative.
I don't even know.
72
72x minus 12.
minus 12. Okay, the fourth derivative.
72.
72 The fifth derivative?
X
0.
0. 72 drops out. Okay, what's the nth derivative?
0.
We're going to run out of terms, right? Eventually we keep narrowing down. So the 11th derivative, the 12th derivative, the 32nd derivative is going to be 0. Anything after the 5th derivative is 0, right? He just cancels out. Yeah, that was kind of a fun process. So like it's derivative after derivative.
What does that mean?
Like, I liked those
The
ones.
second derivative, usually we don't do anything with anything higher than the second derivative, but first derivative is velocity, right?
That's it?
Second derivative correlates with acceleration.